Hello students, today we will discuss the main topic, that is types of covalent bonds. In the last class we discussed regarding how the covalent bond is formed, what is the difference between covalent bonds and ionic bonds, but if you see the nature of molecule, although molecules are covalent, has covalent character, but the natures are not same. It depends upon the types of covalent bonds present in the molecule. Both bonds are produced by a sharing of electrons, but the nature of bonds are not same. Let us discuss the types of covalent bond and how the covalent bond is formed in the molecules. Okay, so see, for example, formation of hydrogen molecule. If you see the formation of hydrogen molecule, it is produced between two hydrogen atoms. Each hydrogen atom carry one electrons. These two hydrogen combine. But during combination, if you see, both hydrogen has a single electrons. Then these two electrons, when these two atoms come closer, then they contribute one electron each and forming the covalent bonds. This is your formation of hydrogen molecules. So, as two electrons shared by the both atoms, so the molecule is a what? Single bonds. Formation of single bond. So it is a single bond. If you see the oxygen molecule, then it will produce two oxygen atoms. And both oxygen atoms have how many electrons? Oxygen has 6 electrons. So out of 6 electrons in outermost shell, so we can write like this. These are 6 electrons. Six electrons, they demands another 2 electrons to satisfy octet rule. That's why they contribute 2 electrons. Both oxygen contribute 2 electrons because they have shortage 2. So it will be contributing, each oxygen contributing 2 electrons, then remaining 4 electrons on the oxygen atoms. So this is the shared pair of electrons, 4 electrons shared by the both oxygen atoms, because each oxygen requires 2 electrons. That's why they are contributing 2 electrons to satisfy octet rule. That's why here 2 bonds are produced between oxygen atoms. In the oxygen molecule, 2 bonds are there, and these 2 bonds, it is called double bonds. It is called single bonds. Similarly, if you see nitrogen molecule, that nitrogen atom has 5 electrons in outermost shell, that is here 2 electrons, remaining 3 electrons here. Another nitrogen atom, same, it has 3 electrons, and as it has shortage of 3 electrons, already it has 5 electrons, then it demands another 3 electrons to satisfy octet rule. So as it requires 3 electrons, so both nitrogen atoms contribute 3 electrons, and both electrons get shared by the both atoms. So to satisfy octet rule, so 2 electrons remain in nitrogen, and the contributed pair of electrons will remain in between two atoms. So if you see this is your shared pair of electron between two nitrogen atoms in the nitrogen molecule. So it becomes N triple bond N and having two non-bonded electrons in both atoms in nitrogen molecule. So it is called triple bond. N triple bond. So that is one question, that hydrogen molecule has only a single bond, oxygen molecule has one double bond, and nitrogen molecule has triple bond. But one question is, these two bonds and three bonds, are they equal in nature? If you break, that is one important thing, to remove this, to break this bond, that energy required. Here two bonds, both bonds, to energy required the first bond, then energy required to break second bond are not equals. These two bonds between oxygen molecules have no equal bond energy. Their bond energy are different. That's why the nature of bonds between oxygen molecule are not same. They are also different. Similarly, in nitrogen molecule, triple bonds are there because three electrons contributing, as each nitrogen atom contributing three electrons and producing triple bond. Add oxygen contributing two electrons to satisfy octet rule and forming double bonds. But it has been observed these two bonds of oxygen molecule are not similar in nature. How it will be known? If you want to break the oxygen molecule, the energy required to break first bond is not equal to energy required to break second bond. That's why bond energy of two bonds are not equal. Similarly, the bond energy of these three bonds are not equal. That means the nature of bond in triple bond are different, and the nature of bond in double bond also different. That means some formation, the nature of formation, the quality of bond are different in oxygen molecule and nitrogen molecule. These two bonds are not equal and these three bonds are not equal. So what is the difference of the formation of these bonds? Then what type of bond formation observed? How the bond is formed in nitrogen molecule, in oxygen molecule, only can be explained by the overlapping concept. It cannot be explained by the sharing of electron concept. Only sharing of electron concept can be explained only the formation of double bond and triple bond, as each hydrogen is contributing single electron, so a single bond is produced. As it is contributing two electrons, so double bond is produced. As it is contributing three electrons and triple bond is produced. Only this can be this concept only explained by the sharing of electrons. So, but how they differ in nature only can be explained by overlapping concept. Only that is called overlapping concept. Overlapping concept of orbitals. This overlapping concept of orbitals can explain the difference of the nature of bonds. So only sharing concept cannot explain, but overlapping of orbital concept can explain why the two bonds are different and why the three bonds are different. But before that overlapping concept of orbitals, we have to see orbitals generally S orbitals, which is spherical shape, and P orbital, which is dumbbell shape, and D orbital, which is double dumbbell. This is your P orbital, this is S orbital, this is D orbital. This is spherical shape, this is your dumbbell shape, this is double dumbbell shape. Already we have read in atomic structure. So F orbital is not generally, because it has complicated shape, generally will not be discussed here. Only S orbital, P orbital and D orbital involvement we will discuss. So these are the three main types of orbital involved in the formation of covalent bonds. So if now we discuss what type of bonds, what is the nature of bonds produced, what type of covalent bonds is produced during overlapping of orbitals. But previously only we discussed the sharing of electrons. When two electrons shared by the both atoms, single bond. When 4 electrons shared by the both atoms, double bond. When 6 electrons shared by the both atoms, triple bond produced. But what are the nature of bonds? We will explain by overlapping concept. So one thing you remember, when S orbital combine with another S orbital, this is S orbital, this is also S orbital. When this orbital overlap, this is the overlap region. This is S orbital, this is S orbital. When two orbital, S orbital is spherical shape. When they come closer, when they will touch one another, they will crush one another like this. When they are coming, they will come only axially or head to head. Head to head overlapping or axial overlapping. This type of overlapping is called head to head overlapping. Head to head overlapping. Head to overlapping, or it is called axial overlapping. Head to head overlapping or axial overlapping. When head to head overlapping or axial overlapping is produced, this type of bond is called sigma bond. This type of bond is called sigma bond. This type of bond is a sigma bond between 2s. Similarly, if S mix with P, S mix with P, then the overlapping will be like this. They will overlap in this way. S overlap with P. This is the overlap region. And this type of overlapping, this is your P orbitals, this is your P orbital, this is your S orbital. When they overlap head to head or axial way, axial manner or head to head overlapping, forming sigma bond. So sigma bond is one type of covalent bond which is produced by head to head overlapping or axial overlapping of orbitals. So S overlap with P forming sigma bond. S overlap with S producing sigma bond. Similarly, P, this is the first overlapping, this is the second overlapping, then third overlapping. When P overlap with P, P overlap with P, it produce sigma bond also. This is the overlapping region, but it is any. It is a P orbital, it is also any P orbital. So producing sigma bond. This is also sigma bond formation. So like this, D can mix with S, like this formation of sigma bond. So sigma bond can be produced by overlapping of any two orbitals. Any two orbitals overlap axially or head to head manner forming a sigma bond. Then how other type of covalent bond will be formed, let us discuss. Suppose P orbital is coming in this way. This is a P orbital. Suppose it is a P orbital, it is a Px. You know, P has three types: Px, Py, Pz on the basis of orientation. Px is along x-axis, Py along y-axis, Pz along z-axis. Similarly, D are generally 5 types. Dxy, you have read in class that in atomic structure, dxy, dyz, dzx, dx square minus square and dz square. So this is the 5 types of what? Orbitals. dxy, dyz, dzx, dx square minus y square, dz square. These are the 5 d orbitals. These are the 3 p orbitals, and these are 1 s orbital. S subcell has 1 orbitals, p subcell has 3 orbitals, and d subcell has 5 d orbitals. Already you have read in atomic structure. So any orbital when come closure axially or head to head manner forming a sigma bond, always forming this is the sigma bond formation. S with S, S with P, P with P forming sigma bond. But you see one type of overlapping when Px coming with another Px, because you see their orientation is same. This is the x-axis. This above the x-axis one lobe and below the axis another lobe is same above and below. And these two orbitals come closure in which manner? Sidewise manner. This type of overlapping is called sidewise. Sidewise, how they will form sidewise manner? Just they will come closure like this. This is your axis. If you see this is your axis, then one orbital you can show like this. This axis, so this is the overlapping region. That means here above the lobes above the axis just touching one another, and the lobes below the axis also touching one another. So this type of overlapping is called what? Just it will become like this. These are two, upper lobe and lower lobe. Upper lobe, just they will come and touch one another like this. They will touching upper lobe with upper part, lower lobe with lower part. That's why this type of overlapping is called sidewise. Sidewise overlapping, or it is called lateral overlapping. Sidewise overlapping or lateral overlapping, this is called pi bond. This type of covalent bond is called pi bond. So how pi bond is produced? Just above the axis and below the axis. That means both similar type of orbitals can form pi bonds. P with px, Px with Py, similarly Py with Py forming pi bond, Pz with Pz forming pi bond, but Px cannot form pi bond with Py, Py cannot form pi bond with Pz, Pz cannot form pi bond with Px because pi bond is not possible. Here pi bond not possible. Pi bond is not possible. Why? Why not possible? What is the cause? Why pi bond is not possible? Because Px orientation along x-axis. py orientation along y-axis. X-axis and y-axis, the orientation are different. They cannot touch sidewise or lateral way. But in the lateral way, in the sidewise manner, px, py cannot touch. That's why pi bond is not possible between px and py. Similarly, py, pz, similarly pz and px, not possible. Only pi bond is possible between same type of orbital, px with px, py with py, or pz with pz, forming pi bond only sidewise overlapping. Okay? So another thing here you write, very important thing, you can write, you put star mark and write down s orbital cannot form pi bond. Why? Why s orbital cannot form pi bond? What is the cause? S orbital cannot, because s orbital only one orientation. As it has one orientation, it cannot be oriented with respect to x-axis, y-axis or z-axis. As it has one orientation, it cannot fit with the p. You see, p orbital has two lobes, above and below. But s orbital, if you see, this is your s orbital and this is your p orbital. This is your px, this is s. But how the pi bond is produced? Pi bond will not be, because it has its lobe is above and below the axis. If it has a particular axis above and below, then it can form sidewise overlapping. So sidewise overlapping is not possible here. Only head-to-head overlapping is possible. So this type of overlapping is not possible, the formation of pi bond. Pi bond cannot be produced between S and P, any P. If you take S with any P, pi bond cannot produce. S with any P orbital, Px or Py or Pz, only sigma bond can be produced. So this is the regarding formation of sigma bond and formation of pi bond. Then we will discuss that how the pi bonds and sigma bond is produced with different molecules. Already discussed regarding the formation of sigma bond, pi bond. Then what are the different types of bond, covalent bond produced in the molecule? Let us discuss. For example, that H2 molecules. H2 molecules here, 1s1, H has 1s1 mixed with 1s1. That means how? Here s orbitals overlap with s orbitals. This is the formation of sigma bond. S orbital, this is 1s1 having unpaired electron. This is 1s1 forming sigma bond. For example, if you see oxygen molecule O2, just already we discussed this one. Like here, how double bond is produced, we'll discuss here. Here double bond is produced in this way. Here, just you see, oxygen O8. O8 means 1s2, 2s2, 2p2, 2p4. This is 2p4. 2p4 can be written as 1s2, 2s2, 2p4 is, you can say, 2px2, 2py1, 2pz1. Applying Gould's rule. So how many unpaired electron available in oxygen? 2 unpaired. Here in Y1 and in Z1. All other orbitals carrying 2 electron. 2 electron means it is fulfilled. So another oxygen atom, same. You can say like this. It will be, you can write here, same way, 1s2, 2s2, 2px2, 2py1, 2pz1. It has also 2 half-filled electrons, 2 unpaired, 2 unpaired. Then there will be a bond between Y with Y, then Z with Z. Here S overlap with S, here py overlap with py and z with z. How? So this is your oxygen atom. Here this is your one orbitals and this is your another orbital. So it is your py, it is your pz, y1 z1 is half filled. This is also carrying one electron and this is also carrying one electron. Then mix with another oxygen. Similarly, another oxygen also same. This is your py carrying one electron. This is your pz carrying one electron. Both carrying one electron. Then when they will mix, you see, both it will come closer and it will also come closer. When this low py and py coming closer in axially, when they are coming axially, they overlap in this manner, forming sigma bond. Then pz, this is your pz, this is your pz, this is your also pz, this is your py, and this is your also py. So this type of overlapping is axial overlapping forming sigma bond, and this type of overlapping when they will come closer and touching like this, they will come upper lobe coming upper part, lower lobe coming lower part, forming pi bond. So 1 sigma 1 pi. So it can be written as O double bond O 1 sigma 1 pi. Okay. Similarly, this is regarding formation of 1 sigma. This is the formation of 1 sigma 1 pi. That means 1 double bond contain 1 sigma 1 pi. Then third example regarding nitrogen molecule, that is N2 molecule. Here what happens? Here N means N7. 7 can be written as 1s2, 2s2, 2p3. 2p3 can be written 2px1, 2py1, 2pz1. Already you have read Holmes rule. 3 electrons can remain in 3 orbitals of p. Similarly, another nitrogen having same contribution 2s2, 2px1, 2py1 and 2pz1. Both having same 2pz1. Then same as both are happy. It is happy. So x with x, y with y and z with z forming the bonds. How? Suppose this is your nitrogen atom. This is your nitrogen atom having one orbital is like this, another orbital is like this, another orbital is like this. So this is your px, this is your py, this is your pz, each having one electron. Another nitrogen same like this. This is your px, this is your py, this is your pz. When both come closer, then x with x will come closer, y with y will come closer, and z with z will come closer. Then how they will form bond? So first they will overlap in this way, x with x, that is formation of sigma bond. Then Z with Z, here Z with Z, forming pi bond. This is your one pi bond. The remaining another Y will be also like this. This is also Y, like this. So Y with Y and Y with Y. This is also forming another pi bond. So how many pi bonds are formed? 2 pi bonds. Y with Y, 1 pi bond, Z with Z, another pi bond, and X with X forming sigma bond. That means X with X axially overlapping, Py with Py, Py with Py, that is lateral overlapping or sideways overlapping, and Z with Z forming pi bond due to sideways overlapping. So nitrogen molecule is N triple bond N. So how many? 1 sigma and 2 pi. Out of 3, 1 sigma bond and 2 pi bond. This is your sigma bond and this is your 2 pi bond. So triple bond contains 1 sigma and 2 pi, and double bond contains 1 sigma 1 pi, and your single bond here, single bond, that is you can write H hyphen H, only sigma bond. So single bond contains 1 sigma, double bond contains 1 sigma 1 pi, and triple bond contains 1 sigma 2 pi. Then what is the difference between sigma bond and pi bond? If you write, this is the difference, just to write difference of sigma bond and pi bond. If you draw this here, first point is produce, suppose this is your sigma bond and this is your pi bond. If you write, and sigma bond point, it is a strong bond, stronger bond, but it is a weaker bond. Why? Why sigma bond is stronger bond? Because the extent of overlapping is more. Because their orbitals are coming head to head. Head to head, that means contact will be more. But sidewise overlapping, contact will be less. So the extent of overlapping is more in case of sigma bond due to side, that is head to head overlapping. That is a stronger bond, it is a weaker bond. Then another point is free rotation is possible. Free rotation, for example, I will tell you, suppose this is a single bond, here free rotation can be possible. Freely molecule can be rotated. Free rotation is possible in sigma bond. Two atoms can be rotated freely along sigma bond. But in case of pi bond, free rotation is restricted. Free rotation is restricted. How? For example, you see, this is just one bond, but when two bonds will be in between the two molecules, rotation is not possible. You see, one bond is opposing another. Molecule cannot be free. You can try. Now you can try. Just you try taking just you take one pen and try. If you rotate your hands, it is easily freely rotated. But if you take two pens, then you try to rotate by catching the two pens at both ends. If you try to rotate your hands, it cannot be rotated because the pi bond, you see, pi bond is produced above and below the axis. As it is produced above and below the axis, free rotation is not possible. That's why molecule cannot be rotated freely along pi bond. If it has a pi bond, free rotation is restricted. But if it has a only single bond, only sigma bond, then free rotation can be possible. And sigma bond is a stronger bond due to greater extent of overlapping, and pi bond is just weak overlapping, very extent overlapping is very low. That's why it is a weak bond. Then another important difference is S orbital, P orbital, D orbital, both can form sigma bond. S, P, D, F can form sigma bond. But here, what? S cannot form pi bond. Why S cannot form pi bond? Because S has only one orientation. As it has one orientation, it has no above and below the axis, some lobes are there. As it is one, that is spherical shape, so only head to head or axial overlapping is possible. No sidewise overlapping is possible in case of S orbital. That's why S orbital cannot form pi bond, but all other orbitals can form pi bond, but the restriction is it should be same orientation, px with px, py with py, like this. But px and py cannot form. Similarly, px with py cannot form pi bond because their orientation are different. Their lobes are oriented in different axes. That's why overlapping is not possible. That's why pi bond will be possible in case of similar orbitals, and S cannot form pi bond. But sigma bond can be produced between all types of orbitals, both because orbitals can touch one another axially. So this is regarding the types of covalent bonds, sigma bond and pi bond, how sigma bonds are produced in the molecule, and why sigma bond is stronger bond and pi bond is a weaker bond, why s orbital cannot form pi bond. These are some important description and explanation regarding the types of covalent bonds. Okay, thank you.